our next shortcut rule for taking derivatives. It's called the sum and difference rule. If I want to take the derivative of two functions added together, I can just take the two derivatives and add them together. Similarly, if I want to take the derivative of a difference, I can take the derivatives of the two functions and subtract them. Make sure you distribute the subtraction. So I want to jump down here to these two examples from your paper. If g of x is 3 over negative 2x raised to the fourth, minus x over 2 plus a fourth, I'm here. Oops. Here. Our first step is to rewrite this so it looks like some constant multiplied by a power of x. So I'm going to multiply out that denominator. I get 3/16 x to the negative fourth minus 1/2 x plus 1/4. Now I can take the derivative. This negative 4 exponent comes to the front to multiply the 3/16 that's there. My new exponent is going to be 1 less. I can simplify. I get negative 3/4 x to the negative fifth minus 1/2. Notice there's nothing here because the derivative of 1/4 is the derivative of a constant, which is 0. If you look at that last example that's on your paper, we've been given h of x is x squared plus 1 times 2x minus 5, and we've been asked to find the derivative. The derivative of a product is not the product of the derivatives. If I want to find the derivative of h, I'm going to have to rewrite it so it looks like something I do know how to find the derivative of. In this case, sums and differences. So multiply it out. I get 2x cubed minus 5x squared plus 2x minus 5. Now I can take the derivative. The 3 comes to the front. The 2 comes to the front and multiplies. I get 6x squared minus 10x plus 2. So one of the most common things you're going to see in the next couple of weeks in most of the rest of calculus is you'll be asked to find the horizontal tangent to a function. So we know how to find the slope of a tangent line. That's to find the derivative. If we want to find the horizontal tangent, we want to find the derivative and set it equal to 0. Remember, a horizontal line has a slope of 0. So here, if y is x to the fourth minus 2x squared plus 2, this one's not on your paper, but it's a good one to follow along because you have a similar one. I can find the derivative. Dy dx is 4x cubed minus 4x. And now I want to set that equal to 0, so I can find where the tangent line has a slope that is 0, where the tangent line is horizontal. So I have 4x cubed minus 4x equals 0. You'll remember we solved equations like this on that paper at the beginning of the school year. That's to practice for exactly this moment. Can divide both sides by 4, factor, and we end up with 3 solutions. X is 0, x is negative 1, and x is 1. Now we've been asked to find the horizontal tangents. Horizontal lines are written with an equation y equals. So if we could know the y-coordinate of each of the places where the horizontal tangent occurred, we could find the equation for that horizontal line. So if I plug in 0 to my original function, there we go, plug in 0 to my original function, I get 0 squared minus 2 times 0 plus 2, I get y equals 2. If I plug in negative 1 and 1, both of those times I happen to get the same value, y equals 1. So let's see a picture of what this looks like when you actually graph it. We promised you a horizontal tangent. So here's the original function. At x equals 0, we said there was going to be a horizontal tangent at y equals 2. So notice that 0, 2 is a point on the graph. And if you tried to line your pencil up so that it was tangent to the graph, you would see that here, where the graph turns around at y equals 2, the tangent has to turn around and it flattens out for a second. That's how we get a horizontal tangent. Same thing here at negative 1 and positive 1. I have a horizontal tangent. The slope is 0, and that happens to connect both here at negative 1 and 1. And just for discussion, if you did come here and graph the derivative, which we said was 4x cubed minus 4x, notice that the derivative is in fact 0, here at negative 1, at 0, and at 1. There we go. Product rule in the next slide. Set.